Okay, so here's our review video for week 1. Remember, this is optional. You do not have to watch the whole thing. The first minute, probably less than that, I'm just going to kind of zoom in and show you the answers for the first few problems, and then I'll go on and solve a few of them or explain them. Notice on these last few, this ... right here is a place for you to have an explanation. So I'll talk through that explanation, but as long as you have something written, you're probably on the right track with those. Okay, so let's head back to the first page. Questions 1 and 2 are both asking about distance. Remember distance, you can remember the distance formula, or you can just do Pythagorean theorem, which I think is going to be easier there. If they have a figure drawn for you, you can just draw yourself a right triangle and count the sides. So I've got 3 and 6. So you may be setting that up 3 squared plus 6 squared equals c squared. Just know in the end you're going to be taking the square root. I just have written that I'm taking the square root at the very beginning because it's going to be the same thing. So when it says find the exact distance, that's going to be my square root of 45. But when we talk about estimating the distance, remember what we had done on Monday. So we find the closest square root, which is going to be 6. How far away is 36 from 45? That's 9. And then 12 comes from doubling that whole number that we picked. So the square root there is approximately 6.75. Similar process on question 2, but to find my two sides, I just want to find the difference between the x values and then the difference between the y values. So how far apart are -5 and -1? And those are 4, so I'm going to use 4 squared. And then how far apart are 4 and 6, which is 2, so 2 squared. Same process over here to approximate that square root. Or when we talk about finding the midpoint, we said that was like the average. So the idea there is we want to add the two numbers together and divide by 2 because there are 2 values. If they give you a graph, sometimes you can just kind of eyeball where the middle is, which is what I've done there on number 3. You may have written that as -2.5 or -5/3. All of those are equivalent, so any of those answers will work. And then on question 4, so like I just said, I'm adding the two x values together. -8 and +7 is -1 divided by 2. And then add the two y values together. 2 plus 5 is 7 divided by 2. So right there, -1/2 and 7/2 is going to be my midpoint. You could also say -1/2 and 3.5 or -0.5. All of those, again, are equivalent. 5 and 6 are a little bit different because in 5 and 6, they give me another endpoint. So what I like to do, you may have another way to think about this, which I would actually really like to hear what you all do if you do something different. But I think, okay, so this is in the middle, my 7/8. So if I go backwards 1 to get to 6, I'm going to have to go forwards 1 to get the next x value, which is going to be 9. If I have to go backwards 17 to get to -9, I need to go forward 17 to get 25 on the other endpoint. All right, same kind of idea with question 6. So we're just thinking about how are we getting the different directions for the x and the y coordinates. You can always go back and add these new endpoint values together and divide by 2 and see if you got that midpoint if you just wanted another way to check. Question 7, we're just going to start solving. So this is segment addition. You do not need to write how you're adding the segments together as far as like in notation using the letters themselves. But I have here set up an equation. So I've got 6x plus 1. So it's like the two small pieces added together give you the larger piece, which is exactly what I've done here. And then I'm just working out the algebra and I get x equals 1. It's always really smart to go back and plug that in to just make sure that you've done that correctly. Because sometimes they won't just ask for x, they're going to ask for other values as well. So if I plug that in, I get 7, 7, and 14. So that actually does work. All right, very similarly on questions 8 and 9. So there are two things that are a little bit different. So let me zoom in on these. So on question 8 here, notice that there is some overlap. So you kind of got to think about how you're going to set that up. There are a few different ways, but what I did was I focused first just on this section that says 12x. So if I know all the way from G to I is 12x, and h to I is 2, then this other part must be 12x minus 2. It's whatever's left over. So once I filled in that other small piece, it was a little easier for me to set that up using, to set up an equation. So I did segment addition from F all the way to H right here. So I'm going to do the 11x plus 12x minus 2 is going to give me this entire length of 21. You could have done that another way, like there are other ways to have solved that, but that's just what I chose to do. So then I'm just doing my algebra and getting 1. And remember, it does, and you should always go back and plug this in, like I said, just to make sure that the numbers you're getting do in fact work. All right, question 9 is easier in its setup because you're just setting this up, the two smaller pieces add together to give you the larger piece. But notice what the question is asking. It is not asking for x, it's asking you to find TV. So whatever you get, you need to plug back in. Now that's kind of a trick question here because TV is the same or equivalent to x. Notice that I did plug 11 into TU though, just to make sure that again it worked. And once I plugged that in, I got 3, and obviously 3 plus 8 is 11, so that's still valid. All right, question 10, name the angle in 4 ways. I think you all have that down. Just remember that H being the vertex needs to be the middle letter whenever you name the two angles using 3 letters. When can you not name an angle using the vertex? If multiple angles share the same vertex, you all got that in about no time when I showed you earlier this week. But remember, if you've got multiple angles coming from the same vertex, you can't use just the letter V because it's impossible to know which angle you're talking about. Questions 12 and 13, that's just about how to use the protractor. I think you all have that down. Just remember you want to make sure that the little bubble that you're going to use is lined up perfectly on that vertex and that you use the number that makes sense. So if you're going for an obtuse angle, you want to pick the number that is an obtuse angle measure. If you're going for an acute angle, obviously pick the number that gives you the acute angle measure. If you need help with either of those skills, you can talk to me before your test. All right, question 14, last one on this page. Now we're talking about angle addition. You could have written out the notation for that, which we will work on a little bit more next week, and that is to say the measure of angle KLR plus the measure of angle RLM equals the measure of angle KLM. That's just kind of saying, right, the two smaller angles come together to give you the larger angle. What I like to do, especially since this doesn't give you any specific instructions, it's literally just asking you to find the measure of angle RLM. I just take as much information as I can and put it on the picture. I'm just a visual person, so that helps me. So I know this small angle is 20. And I know the entire thing is 180. Sometimes, now I didn't write it on this one, but sometimes if I'm doing the whole thing, I just kind of do an arc going over the whole thing so I know what it is applying to. And then simple subtraction is going to give you 160 there. All right, 15 and 16, we're nearing the end here. So on 15, again, I told you I like to put the information on the picture, so that's what I've done. Because easily now I can see the small piece, 6x minus 2, plus another small piece, 14x minus 5, equals the entire angle measure, which is 93. Simple algebra is going to get us to 5. And then it is a good idea to go back and plug that in and make sure that that works. And if I do that, 6 times 5 is 30 minus 2 is 28. 14 times 5 is 70 minus 5 is 65, and 28 plus 65 gives me 93. So I know that x does actually equal 5. 16, similar. You can see that I just put the information on the picture. I've gone through, set up my algebra and solved all that out. And then note the difference, the biggest difference here is that it's actually asking you, if you read the question, for angle UFG. So it doesn't just want to know what x is, it wants to know the actual angle measure. So I've gone through and I've plugged 11 in. So I know that, UFG rather is 83. And then UFE, when I plugged 11 in over there, I got 90. And 83 plus 90 is 173. So my math is all working out there. All right, this bottom section is really just to make sure you remember what the different markings mean and to make sure you know that you can't just trust what a picture looks like. It has to be stated. So in example 17, it's asking if the two angles given are congruent. Remember, that's what that little equal sign with the squiggle means right there. That means congruent. So are they congruent? Yes, they are, because they both have the two arcs, right? These two little arcs show that those two angles are congruent. Example 18, are DE and EG congruent? No, they are not. Now the angles D and the angle G are congruent, especially if we talk about these interior angles right here, right? The angles are congruent, but the segments are not. If the segments were congruent, we would have had to see these little like tick marks or hash marks on those segments, but we don't see those, so we don't know that they're congruent. All right, question 20. TSR, is that 90 degrees? Again, no. We would only know it was 90 degrees if we had seen the little box drawn there, but because it is not marked as 90 degrees, it is not 90 degrees that we know of. So something like that is what needs to be in your explanation. And then question 20 here at the end, B, C, and G, F, those are congruent. They both have the double hash marks that segments require to show that they're congruent. Just so that you know, right, DF and DC are also congruent to one another. However, DF and GF are not congruent to each other because one of them has one of the hash marks and the other one has two. So as long as you're familiar with that notation, you should be good for tomorrow. All right, so this is, I just want to kind of give some explanation if you didn't follow what Khan Academy had to say about it, about these two questions, which you have probably had similar questions if you did the Khan Academy section, even though they have, will have had different, obviously, letters. These are kind of some trick scenarios. So you know, and I think you know, that coplanar means all 3 points are in the same plane. So for instance, if I asked you if E, A, and M were coplanar, hopefully you would say yes, seeing that all of them are on that plane. If it said E, A, M, and I, okay, those are not coplanar because I is very clearly in a different plane there. The reason that these are trick questions is because it takes 3 points to make a plane. So if you look at E, I, and A, as it's, I mean, we can't see the plane that is on, but those actually do make a plane themselves. So, I mean, I can kind of connect those to show you like a triangle, but think about if that triangle was its own piece of paper, right? That's its own flat surface. So even though it's going a different direction than the plane that you see, it doesn't mean that it's not still a plane. If you need me to kind of show you a visual of that 3D wise, I can. But just know that the answer, are those coplanar? The answer is yes. Any 3 points you are given will always be coplanar. Any 3 points. It's when you have 4 for planes that you have to question, are they all in the same plane or not? Okay, so very similarly on the second question here, are the points M and O collinear? So it might be almost easier for you to make sense of this problem here. M and L, right, very obviously collinear, sorry. M and U, again, collinear. M and O, they don't look like they're on the same line because we don't have the line that they're on drawn, but we can draw a line using M and O, and so yes, they could be on the same line. So that is an example of two things that are collinear. The same way that M and X, right, they don't look like they're collinear, but it would be possible for me to draw a line through M and X. So are M and O collinear? Yes, they are. An example of them not being collinear is if they gave you 3 points that were not in a line. For instance, if they said M, X, and L, right? That's M and L are on the same line, and L and X are on the same line, but not all three of these. I cannot draw a straight line that's going to cut through all 3 points, so that's an example of something that is not collinear. If you have any questions about these or any of the other problems from the review, do your best to come to tutoring in the morning and just try to ask me real quick before our test so that you just have a chance to kind of get some things cleared up.